Hi children, today the topic what we are going to say is grouping of capacitors or condensers. Okay, capacitor, condenser, everything is same. Okay, now how to group? There are two modes of grouping the capacitors. How to group the capacitors? There are most common modes of grouping of capacitors. Means one is first A is in series combination capacitors in series, and B capacitors connected in parallel. Okay, just in your 10th standard you would have studied resistance in series and resistance in parallel, like that. Now we are going to connect capacitors in series and capacitors in parallel. Okay, so now first one, what is that? Capacitors in series. Now we are going to see. Okay, first one, capacitors in series. Right, what is it? See, I have let me have three capacitors. Okay, and three capacitors having capacitances C1, C2 and C3. Okay, so I have capacitor, three capacitors. Okay, parallel plate capacitor or whatever. See the capacitors, we are having only what is in syllabus, only parallel plate capacitors. Okay, so we have three capacitors. Okay, C1, C2, C3. Now I am going to connect them in series. Series means what is that? One capacitor, one plate of the right hand plate and left plate, right plate of the first capacitor. This is your first capacitor and this is the second capacitor and this is the third capacitor. Okay, so all are connected by means of a wire, conducting wire. Okay, first, second and third capacitor. Three capacitors I am taking. Okay, so with that we will see first. What are therefore, and these three capacitors are having capacitances C1, C2 and C3. Okay, now what I am going to do is, and they are connected in series now. So this is okay. This is the series combination of three capacitors C1, C2 and C3. Okay, the right plate of the first capacitor is connected to the left plate of the second, and right plate of second capacitor is connected to the left plate of third capacitor, and the extreme ends of 1 and 3, that is left of first capacitor and right of third capacitor. Now I am going to connect it to, a potential difference here. Okay, I am going to give a potential difference across it. This is positive and this is negative. Okay, and usually what is that? This will be okay, earth. Okay, right. Now what is now let me have, what is the potential I am giving here? The potential across all the capacitors, the total potential given here is okay, V. Okay, so let Q units of charge, now you see, to the first capacitor, to the left plate of the first capacitor. Okay, once it is connected to a potential difference, external, this is the external source, this is the external supply. Okay, once I am connecting the left plate of the first capacitor, okay, actually it acquires positive, therefore it is what actually Q units, plus Q units of charge is given now, which means it is given to the first left plate of the first capacitor because it is connected to positive of the supply now. So what is that here? Okay, which means here this side third plate. So see, right side the third capacitor is earthed. Okay, so but the left side left plate of first capacitor is connected to a positive of the supply. So from there, what is that? This plate, left plate of first capacitor is given some positive charges. For how many positive charge? Plus q units of positive charges given. Are you following? Right. So actually, even I can write this one, the charge. See, it is given. Therefore, here this is the positive charge that is given. Once it is given positive charge, you know by induction, here all are metallic plates only, no? Therefore, by induction, this will become negative. If plus q means it will become minus q. But what is that? The positive charge will be here. Because only separation of charge, induction only. And these positive charges, what happens? Okay, here will be what is that? Positive charge only. Equal number of positive charge will be there. Okay, but this positive charges will be immediately nullified. See, what is that here? Second plate, left plate of second capacitor here. From there, electrons will come here and it will neutralize the what is that? This positive charges. Are you following? Therefore, because electrons are coming from the left plate of second capacitor, hope you are following, in order to what is that? Neutralize this positive charge. Why? Because potential immediately they cannot keep quiet now. Electron here it is positive charge, it will be attracted. It will be attracted here, all the electrons. Therefore, not all the electrons, depending upon how many charges. Positive 5 here means 5 unit will come there. Okay, electrons will come there. Therefore, now you see, because of that, here this positive charge will be nullified. Okay, because the electrons have come here from the left plate of second capacitor, electrons have gone here, which means that it becomes positive, which means that this plate, left plate of the second capacitor will also become positive. Correct? Once again, what will happen? Because of that, the right plate will become negative and this side will become positive, but that is being nullified. Therefore, what is that? Nullified by the electrons from the third plate. Third capacitor, left plate of third capacitor. Are you following? Third capacitor mein left plate A hai. Okay, from there, what is that? Electrons will be coming to nullify these charges. Therefore, it will go off. Okay. Therefore, what will happen? What will happen? Here, once again, it will become positive. Okay. Then, this side, it will become negative. Hope you are following. And this side, it will be positive. But that positive won't be because it is earth. So, electrons from here, electrons from the, what is that, the earth, it goes and it nullifies this positive charges. Hope you are following. Okay. Therefore, now you are getting, I think. Okay. Now, what is that? This plus q, minus q here also, plus q, minus q. Okay. And here also, plus q, minus q. Therefore, when the capacitors are connected in series, okay, the charge stored on each plate, each of the capacitor is the same. Each capacitor is same. Q plus or minus Q. Left plate plus Q, right plate minus Q. In first capacitor, second capacitor, third capacitor, everywhere, the charge stored will be the same. That is very, 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 very important. Okay, when the capacitors are connected in series, note it, when the capacitors are connected in series, okay, the charge stored on each capacitor will be the same. Because charge is the same, okay, you know that what is Q, that is equal to CV. Okay, that you know. Here for the first capacitor, for capacitor 1. Q that is equal to what is because what is that? Your Q is the same. Okay, and Q that is equal to C into V. C into V. C is, what is that? C1 for the first capacitor. For the first capacitor. Therefore, what is the potential drop across the first capacitor, across the plates of the first capacitor will be definitely, it will be different. V1. Okay, how? Why? Because see, V1, are you following? That is V1 that is equal to Q divided by, what is that? C1. Q by C1, potential drop. Okay, even before that I'll come. Therefore, before that, what is that? Potential difference across the plates. Okay, is V1 is equal to Q by C1. Okay, similarly for the second plate, this is V1. Are you following? We consider V1 from here to, you can say it is here, this is V1. Okay, therefore, and like that, what is V2? It is equal to Q by C2, because Q is same. Q, see, the charge is same, but the capacitors are different. Capacitance of each capacitor is different. C1, C2, C3. Definitely that for Q is equal to CV, that formula, the potential drop across each and every capacitor has to be different. Why? Q is same, but C1 is, capacitance is different. Therefore, potential drop across each capacitor should be different. That is given by V1 is equal to Q by C1. Second plate, V2 is equal to Q by C2, and V3 that is equal to Q by C3. Are you following? Okay, therefore it is C1 and this V, it is potential drop. This one is, you can say, okay, even I can write. V2 and A दोनों का पेज में the rest it is V3. Are you following? V1, V2, V3. Potential drop across each capacitor 1, capacitor 2, capacitor 3. And total potential drop is given. Potential drop across all the capacitors is V. All the capacitors is V. Is it clear? Therefore, how to? Therefore, total potential difference, okay, across the combination, across the combination, which combination? Series combination. Combination of capacitors is V, that is equal to V1 plus V2 plus V3, correct? Are you following? Therefore, what is V? V is the total potential drop. Total potential drop across all the capacitors. Total potential drop across all the capacitors, okay, that is V, that is equal to, what is V? V is equal to Q divided by, okay, what is divided by what? The total capacity, total potential difference across all the capacitors is equal to the total charge. Total charge इसमें क्या है? Q only, total charge divided by total capacitance. Total capacitance of series combination. Okay, that is nothing but equivalent capacitance. I think net capacitance. Recall your resistance case. Okay, equivalent resistance and a 10 standard you would have studied that one. Okay, like that here it is equivalent capacitance or total capacitance of series combination, and that is given by CS. Are you following? This is total potential difference is equal to total charge divided by total capacitance. What is total capacitance of series combination? Is called equivalent capacitance of series combination. That is CS. Okay, and that should be equal to what is V1 is by Q by C1 plus Q by C2 plus Q by C3. Are you following? Okay, therefore, now you tell me what should be, okay, whatever Q will get cancelled, therefore you will get 1, CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Okay, so this is the result, required result. Then what is that? 3 resistors are connected in series. Their equivalent resistance, reciprocal of their equivalent resistance, is equal to sum of the reciprocals of the individual, not resistance, it is capacitance. Okay, when 3 capacitors are connected in series, it is not resistance. Okay, anyhow, okay, when 3 capacitors are connected in series, their equivalent capacitance, how to find? It is the reciprocal of the equivalent capacitance is equal to sum of the reciprocals of the individual capacitances. Okay, therefore that implies, okay, now you tell me what is it? Here, if there are n number of capacitors are connected in series, then how to find out what is their equivalent? Even same thing is applied. N number of capacitors connected in series, then what is I? That is equal to 1 to N, okay, 1 by Ci. That's it. CS, this is, it is C. So, what is CS? Equivalent capacitance, okay, of series combination. CS, suffix S. Suffix X says that it is equivalent resistance of series combination. That is sigma I is equal to 1 to N 1 by Ci. Is it clear? Hope you are following. Right. Now we will go to the C. Therefore, what are all the results that we got from this? We are going to list C. Number 1. Okay. When 2 or more capacitors are connected in series, okay, series, then number 1, first result, okay, their equivalent capacitance, no, even it is reciprocal, na? Reciprocal of their equivalent capacitance is equal to the sum of reciprocals of individual capacitances. Hope you are following. Reciprocal of their equivalent capacitance is equal to the sum of the reciprocals of the individual capacitance. This is the result what we got just now. Right. Then, okay, charge stored on each capacitor is the same, correct? Q. When they are connected in series, what is that? Charge on each capacitor should be same, na? Charge on each, charge on each capacitor plate, charge stored on each capacitor, okay, is the same. Okay, then third, what is that? Potential difference across different capacitors are different, na? Different capacitors are different. Correct? Then fourth one is, see, you know that 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by Cn. Okay, therefore, see, the equivalent capacitance Cs equivalent, their equivalent capacitance I will write if you want, because their equivalent capacitance yes less than, it is less than, definitely 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by plus etc. No, less than the least capacitance in the combination. What do you mean by that? For example, okay, how do you say, see, their equivalent capacitance is less than the least capacitance in the combination. For example, C1 is C1 is equal to 1, okay, and C2 is equal to 1, C2 is equal to, you give something, okay, C2 is equal to 2, and 2, what is it, microfarad, 1 means what is it, microfarad, 2 microfarad, and C3 is equal to 3, I am giving you example, okay, to just to understand this. Therefore, what is your 1 by C is is equal to 1 by 1 plus 1 by 2 plus 1 by 3. Okay, therefore, what is that? That is nothing but, if you take from that, what is your CS? CS will be equal to 1 by, that is equal to 11 by 6, na? 11 by 6. 11 by 6. Therefore, what is CS? 6 by 11 microfarad. CS is 6 by 11 microfarad, na? Okay, it is a equivalent capacitance, right? Out of C1, C2, C3, which is the least one? C1, 1 microfarad, correct? Therefore, that is very much less than 1 microfarad. So, which means that out of these three, least one is 1 microfarad. But their equivalent, when they are connected in series, their equivalent resistance is less than the least capacitance, least capacitance in the combination. Okay, therefore CS is less than 1 microfarad, it is capacitance, right? Now, next one. Is it clear? These are all the result with what is that? Parallel series combination. Now we are going to parallel combination. Second one, B is, what is that? Parallel combination of series combination. Now it is capacitors. What I have, the same thing. Capacitors in series and capacitors in parallel. Okay, let me, because I don't, capacitors in parallel. Okay, very simple here. Parallel combination. Okay, see, I am taking, let me go for, so here, all are connected in parallel means, just like your parallel combination of resistors, here it is capacitor, that's all. Both the plates, both the plates are connected with each other. All the three plates, all the left plates are connected with each other, and all the right plates are also connected with each other. Okay, therefore you can say that this parallel combination. Okay, therefore, see, it is the same thing. It is, what is a C1, C2, C3, and I am connecting that to the external potential difference V. Of course it is. Okay, why? Because, and this here, okay, Therefore, what will happen? The same thing here, everything here. What is that? Potential drop across, in this case, what is the difference? Here, C1, C2, C3. The potential drop across each capacitor is the same. Why? C1 is connected to the external supply directly. Both the plates, left and right, is connected to, here it is positive and this is negative directly. Then C2, the second plate. This is the first plate, this is second plate, this is the third plate. Okay, therefore, second plate is also, left plate is connected to positive, right plate is connected to directly to negative of the supply. Like that, what is that here? Third plate also, okay, left is connected to positive and right is connected to the negative of the supply. Okay, so this is negative. Okay, therefore, which says that potential drop across each capacitor is V. Say V. Potential drop is same means, but C1 is, what is that? Different. See, capacitance is different. C1, C2, C3. Therefore, what do you say? Q, charge on capacitor will be different. Q, that is equal to C into V. V is same. Capacitance is different. Therefore, Q, the charge has to be different. Charge on each capacitor has to be different. Are you following? Therefore, let Q1, hope you are following. Okay, you know that Q, that see here, you know Q is equal to CV. Okay, here V is same for all the capacitor, all the capacitors across each plate of the plates of the capacitor. What is the potential drop is the same, but the capacitance is different. Therefore, definitely, what is that? Charge on each charge stored. Okay, each capacitor will store different amount of charge. Therefore, let, hope you are following, ma, Q1, Q2 and Q3, okay, are the charges stored, okay, in the capacitors 1, 2 and 3 respectively. Okay, therefore, now what is your Q1 is equal to first capacitor. Therefore, what is Q1? Q1 that is equal to C1V. Q2 that is equal to C2V. Q3 is equal to C3V. Okay, therefore, total charge, okay, on stored, okay, in the parallel combination of capacitors. Okay, total charge stored in the parallel combination of capacitors. Yes, Q, that is equal to Q1 plus Q2 plus Q3. Okay, that is nothing but, what is that? Total charge is nothing but Q is equal to CV, na? Total capacitance. What is total capacitance? Cp of the parallel combination. Are you following? Q is equal to CV, na? Q is the total charge stored. Total charge should be equal to total capacitance of the parallel combination, that is Cp, okay, and total potential product Cpv, that is equal to, okay, C1V plus C2V plus C3V. Hope you are following. V will get cancelled. Therefore, what is your Cp? Therefore, your Cp, that is equal to C1 plus C2 plus C3. Okay, therefore, this is the result. Okay, what is the total capacitance, net capacitance or equivalent capacitance of what is a parallel combination of three capacitors is given Cp is equal to C1 plus C2 plus sum of the individual capacitances. Okay, therefore if there are n capacitors, okay, if there are n capacitors having the capacitances C1, C2, C3, etc. Cn, then Cp that is equal to sigma I that is equal to 1 to n Ci. Okay, right. Now what are all the results? Now we are going to list the results now. What are the results here? What we have seen here? When two or more capacitors are connected in parallel, okay, then now list the results. Number 1, their equivalent capacitance okay yes is equal to, their equivalent capacitance is equal to the sum of individual capacitances. Correct? Huh? Same thing, you go there in series combination. Reciprocal of the equivalent capacitance is equal to sum of the reciprocal of the individual capacitance. Is it clear? So here it is the capacitance and equivalent capacitance is equal to the sum of the individual capacitance. Right. Number 2. Here the potential difference across every capacitor is same. Correct? When they are connected in parallel, potential difference is same, no? Is same. But which is different? Charge stored, okay, on what is that? Charge stored on different capacitors are different. Okay, charge stored on different capacitors are different. Next one, direct potential difference is different, here charge is different. Then fourth one, Cp is equal to C1 plus C2 plus C3 na. Okay, what do you mean by that? Here see, their equivalent capacitance is equal to the sum of individual capacitances na. Sorry, that you know is sorry, this is what the result is okay, the equivalent capacitances okay is more than okay the largest capacitance in the combination. Okay, see, the equivalent capacitance is more than the largest capacitance in the combination. What do you mean by that? We have taken C1 is equal to 1 microfarad. Okay, here I think I have given you one in the case of series combination. Okay. See, C1 is equal to 1, C2 is equal to 2, C3 is equal to 3. No, the same thing I want to take, that's why. Okay, therefore what is that? C2 that is equal to 2 microfarad and C3 that is equal to 3 microfarad. Okay, therefore what is your CS? CS that is equal to 1 plus 2 plus 3 that is equal to 6 microfarad. Na? 6 microfarad, which is more than the maximum resistance. Largest resistance is nothing but 3 microfarad. Na? Okay, therefore, when the capacitors are connected in parallel, the equivalent resistance will increase. Okay, when the capacitors are connected in series, their equivalent resistance definitely it will decrease. Okay, therefore, if you want, therefore here CS 1 plus 2 plus 3, therefore, there is what is the equivalent capacitance is more than the largest capacitor. Which is largest is capacitance 3, largest capacitance in the combination. Are you following? So this is about what is that? The combination of capacitors. Is it clear? Okay. Now, next topic is energy stored. After that, energy stored in a capacitor. Next topic is, what is that? Energy stored in a capacitor. See, capacitor is meant for storing charge and energy. Therefore, now we are going to see what is the expression for energy stored in the capacitor. This is the derivation we are going to see. Right. Consider a capacitor. Sorry, say actually there are, what is that? A capacitor is a system of two conductors, correct? Carrying one plus Q, another one minus Q. Okay, and which are separated by a very small distance. Okay. See, now to start with, how to see? I have two plates, what is that? Conductor plates. Okay, 1 and 2. Initially, both are uncharged. Okay. So, what I am doing is, see, how to charge. Charging means how to understand the charging. Initially, they are uncharged. Therefore, how to understand the charging? Charging means, let here a positive charge is transferred from the conductor 2 to conductor 1. Positive charge. Okay. And how it is transferred? See, it is not all of a sudden, in very, very small installments of, what is a dq? Every time dq like that, I am, what am I doing? I am taking charge from the plate 2 and I am depositing it on the plate 1. Okay, in the installments, in what is that? dq. Okay, till the charge on capacitor, that is conductor 1, becomes plus Q. Once I am taking the positive charge from 2 to 1, 1 becomes positive. I am taking positive charge from 2 and I am depositing on plate 1. Therefore, the plate 1 will become positive. Correct? At the same time, the plate 2 will become negative. Okay. This till, what is that? I want the left plate, the first plate should become, what is the plus Q, therefore equal the second plate is minus Q. Okay, therefore till then what I am doing? I am taking the charge from second plate and depositing it on the first plate. Okay, so therefore, see, but every stage I am taking, when I am taking like that, see, all of a sudden it will not become plus Q or minus Q, dq in small installments. Once I am taking this charge, okay, first time there won't be anything problem. I'll just like that pull and keep. Once it becomes, after that the first plate becomes positive. Therefore, if the next time when I am bringing that, okay, it is not easy because its potential the first plate become positive. So I have to deposit positive charge on the positive plate. Correct? Are you following? First both are uncharged. Now I am, what am I doing? I am taking the charge from second plate and depositing on the first plate. Okay, first time, okay, once I am depositing like that, what will happen? Slowly the first plate will become positive. Okay, as it is becoming positive like that, then it will be difficult for me to take and once again, and the second plate will become negative. So from the negative plate I have to take the positive charge. That itself is difficult, correct? Okay, because attraction will be there now, and that should be taken and it should be deposited on the positive plate. That is also repulsion. In spite of repulsion, I have to deposit. So therefore, some work has to be done. Okay, therefore, that work done by, what is the work is done by, what is that? Some you have to connect it by a battery, some external supply. Work done. It is not just like that, you cannot. Some work has to be done. Okay, so some work has to be done externally in transferring, okay, the charge in small installments from 2 to 1. That is positive charge from 2 to plate 2 to 1. Are you following? Okay, till what is that? My final, this one is both the plates should get, what is that? The left plate should get plus Q and minus, second plate should get minus Q. Okay, right. Now this is how, what is the meaning of charging. Okay, now the charging process is going on. Okay, slowly, what is that? I am bringing the charge from second plate, I am depositing it first plate, and that is like that. It is slowly going on. Okay, when the charging process is what is that? It is going on. That is okay. Therefore, what happens in between, when it is going on, it is not yet completed. It will get completed only when this plate, both the plates will get plus or minus what is that? Q, capital Q. Only then the charging is over. But now it is not yet over. The what is that? The charge is being taken from 2 and it is deposited on positive charge. That process is going on. Okay. So in the intermediate stage, when it is going on, in the intermediate stage, okay, in the intermediate stage, charges are not yet over. Okay, and stage, what happened? Let plus Q, okay, be plus Q be the charge, okay, on कौन सा plate है? First plate, and minus Q, okay, be the charge on second plate. Are you following? Charging is going on. Okay, therefore it is not yet become capital Q. It is going on. That time, what is the charge? It intermediate stage, when it is going on at any instant of time. Okay, what is that? Let plus Q be the charge on first plate and minus Q be the charge on the second plate. Okay, and let C be the potential, what is the capacitance of the capacitor? C is the capacitance of the capacitor. Okay, therefore at that stage, at that instant, intermediate stage, at that instant, are you following? In the intermediate stage, that time, at that instant, what is the potential difference between 1 and 2 plates, 1 and 2? Okay, yes, what is that? Q by C, na? Q by C, because at that time, what is the charge? Q, and C is the capacitor. Q by C. Are you following? C is the capacitance of the capacitor. Okay, therefore now it is going on. I hope you are following. The charging is not yet over. At any instant, when the charging process going on at any instant of time, let us small q plus q is the first plate charge on first plate, minus q is small q is a charge on the second plate. Therefore the potential difference is q by C. Okay, therefore now if I want to transfer dq amount of charge from plate 2 to 1, at that time when the potential difference is q by C, that time I want to add some more charge dq, okay, from 2 to 1. Therefore definitely some work has to be done. Therefore small work done. Okay, in you can say depositing or in giving Okay, already there is a charge, constant charge q, small q charge is there. Now in addition I am going to give dq of charge, plus giving, okay, an additional charge dq to plate 1. कहाँ से? From 2. That is important now. From there only I am taking. Okay, that is dw. What is dw? dw is equal to, you know that, what is the potential difference? Q by C, na? V into Q, no? Potential difference is Q by C. Potential difference into how much charge I am adding? dq. This is the work done. Hope you are following. Okay, Q by C is nothing but V. V into Q is work done, na? Therefore here Q, what Q here? dq. Why? Because small dq only I am depositing now. Okay, at that instant I am depositing dq amount of charge from, I am taking dq from 2 and depositing on 1. For that, how much amount of work done? Okay, that is this. Okay, therefore, okay, total work done in giving, okay, charge plus q on the conductor to on or to the plate one. Okay, that is nothing but, okay, w. That is equal to क्या है? Integral of dw, ना? That is integral dw क्या होता है? Q by C dq. Okay, what is that? It is, I am going to give charge from B. Initially it was uncharged as 0. From there, what I am going to do? 0 to Q. Within the limit 0 to Q. Are you following me? Okay, therefore, very important. What is work done is nothing but dw is this. Therefore, what is the total work done in order to give charge plus Q to the plate 1? Okay, therefore it is from uncharged 0 to Q by C dq. Okay, therefore it is Q. Okay, therefore what is that? That is nothing but Q by C. Therefore it is Q dq 1 by C. Q dq integration Q squared by 2. What is the limit? 0 to Q. Therefore that is nothing but 1 by C, here Q squared by 2. Okay, that is nothing but half Q squared by C. Half Q squared by C. This is the total work done. And this work done, yes, okay, you can say stored as क्या है? Potential energy. That is electrostatic potential energy. As the electrostatic potential energy in the capacitor. In the, what is that? Capacitor 1 and 2 together in the capacitor. Are you following? Capacitor has 2 plates, 1 and 2. Okay, therefore, what is the work done in taking the charge from 2 to 1? That is stored as the electrostatic potential energy in the capacitor. Therefore, okay, what is that energy stored? In the capacitor, that is nothing but, okay, that is U. Nah? That is nothing but, what is U? That is equal to half Okay, Q squared by C, half Q squared by C. Okay, this is one equation. Now you know Q is equal to CV, no? Therefore, U can also be written as Q is equal to CV. Therefore, I can write also U can be written as half Q is equal to CV. Therefore, CV the whole squared by C. That is nothing but half CV squared, na? Half CV squared. Are you following? Okay. Therefore, next one also U that is equal to half what is Q is equal to CV, and you can even say that see, well, QC combination and CV combination. The other one is I want in terms of QV combination. QV combination. Okay. Therefore, I can how can I write QV combination? May already here half C I don't want because I want only in QV combination. Therefore, half C. What is C is equal to Q by V, na? C that is equal to Q by V. Therefore, Q by V. From this I am telling, okay, Q by is in the place of Y, QC combination, CV combination. Now I want QV combination. So, I don't want C here. C is equal to Q by V into V square, that is equal to half QV. Half QV. So, I am getting three relations for U. U that is equal to U that is equal to, okay, hope you are following, ma. Wait. In this, U is equal to, okay, half Q squared by C, that is equal to half CV squared, and that is equal to half QV. Okay, so this is the relation required. Okay, the same thing you can even what is a plot from the graph. From the graphical method also you can find the energy stored. How? See, by plotting QV graph, you know that what is it? V is proportional to Q, no? Okay, graphically how to attain the same result. Okay, therefore, if you are plotting a graph, okay, between Q and V, let it be Q and here it is V, you will be getting a straight line definitely because they are proportional. Okay, therefore, now for example, this is O and this is A. I am getting some what is that, QV values. I am plotting a graph here, and now I am from this graph, okay, I have to find out the energy stored. How energy stored has to be, I think this way, like that we have done many times, graphical method. Energy stored, from this you have to find out energy stored in capacitor from the graph. QV graph is nothing but, okay, just you QV, na? It is nothing but, I think you can write now area, okay, area OAQ, correct? Slope, this is not slope, it is the area. OA is the, what is that, plot you are getting. Therefore, area, this area, that gives you automatically, what is that, energy, QV. Okay, therefore that is nothing but triangle half into base into height. Okay, base kya hai? Q. Okay, what is half into, okay, base, I'll give you base, OAB, that is ka karo. Okay, therefore half into OB into AB, that is equal to half into Q into V, half QV. Are you following? It is half QV you are getting, na? Half QV. Half QV means it is nothing but half Q squared by C, that is equal to half CV squared by the relation. You will get in terms of Q and V from the plot. Okay, energy stored in the capacitor, that is U. Are you following? So